Hey guys, Pickle700 here, and in today's video I'm going to be giving you guys an update to the access control system. Let's get into it. So I installed this system a few months ago. I can't remember exactly how long ago, and nothing really has changed. It's pretty much the same. I've had no issues with it, but some of my videos of installing it were kind of long, so I'm going to make a more simple video of what the system is. Here is the access control panel. If we open that up, you can see there's some fobs in there, some cards, and some random keys to some doors. So right here, this first terminal block with 5 conductors going into it, that's just Cat5 right there. That is for communicating to the card reader. That is power, ground, LED, and then the 2 communication wires. We have one for a second reader that's not in use. And then this is a door exit button. Then we have our power going into the board, and then our door 1 relay right there. Right here is a network card, which this can be plugged in via Cat5 cable to a switch. So you could communicate with this and program it remotely. Here is the power supply, and then this gray cable right here, that is what is powering the electronic strike plate, which both of those go through this conduit, which I did an offset and some bends going around, up, over the door closer, back down, and to this first junction box that goes directly onto the other side. It meets up with the fob reader right here. Then we also continue down to right here, which is for the electronic strike plate. So you can get a few different sizes of panels. This is a 1-door, they make it 2-door, and there's a 4-door. So all of these fobs are all programmed into the system. You can have hundreds of fobs on the system. I only have, I believe, 12 or 13. Here's one of my fobs here. As you can see, it has my name and what hours of access. All of them have 24/7. I plan to have a couple loaner ones have more restricted access, but I never got around to it. So all of these fobs are 125,000 hertz, which is not the most secure type of fobs, being that they're not encrypted and can be duplicated pretty easily. So they're certainly not the most secure system because of that they're not encrypted and can be duplicated pretty easily with duplicators, and if you have a rewritable card. Basically inside this card there's a coil of electrical wires, and basically this reader out here is constantly giving out power, and when it goes in line with the coil, it'll power up the little chip inside of here, which will communicate back to the fob reader the credentials of this card. That's the same deal in one of these fobs. Obviously it's a smaller coil, and therefore you have to have the fob a little bit closer, right about 1 inch. This one not much closer, but a little bit closer it has to be. But they all do the same thing. If it has the right credentials, the light goes green, and I'll wait for the lock again. Might have been able to hear that. You can hear a relay click, which allows the electronic strike plate. Oh, that locked on me again. But once the credentials have been put in, the strike plate can open up like that, and you might have been able to hear the solenoid inside click again. So if I release this, it will go back into lock mode. As you can see, locked again. And this can hold up to 2,000 pounds of force. So as I mentioned, this is 125,000 hertz. They also make another type of fob. I'll see if I can find one here. Yeah, here's one of those that is. And this will not work on this reader. One, because it's not programmed in and it won't even read it. See, won't even read the fob. But if I take another 125,000 hertz fob that is not programmed in, such as this one, it'll still read it. As you can see, it blinks. So here is another 13.56 megahertz encrypted fob. Won't read it. I can't show you the fob because it has information on it like that I can't show you guys, but won't read it at all. So back to the strike plate. How the strike plate works is, as you can see, it's locked, but once you present it a fob that the system approves of, you can probably hear that relay not only in this guy itself, but there's also the relay on the panel that you can hear. And that relay will then close the circuit, allowing this to get 12 volts power. And once it gets 12 volts power, then the solenoid inside will retract, therefore this can be pushed open. There, that relocked again after 3 seconds, which you can change the time on when it relocks. So since this relies on power to unlock, that does mean in a power outage that you will not be able to access. That's why it is always good to have mechanical override. I'll take one of the keys in here. I believe this is a key for it. This is a Schlage storeroom function key and knob. Yeah. So you can always mechanically override it with the key. It only turns one way, and that will still suck in the plunger, which will bypass the strike plate. So there's that. This is just a standard C keyway 5-pin. So this, like I said, is storeroom function, which is good because from the inside there's no way to unlock the door. All it does on the inside is you can turn the knob to open it and close it, but it always defaults to locked. And even with the key on the outside, it will always stay locked, and there's no way to unlock it. Like in there, it contains the key. There's no way to take it out. The only way to take the key out is in the middle position, which is locked. Another important thing is to have the strike plate set up correctly to align with this pin right here. I can't remember what it's called, but basically if it was like pushed too far back, like behind the strike plate, that this was sticking behind the strike plate too, you could slip something between the door, like a slim piece of plastic, and push that all in. But whenever this one is pushed in, the big one won't go in. So in order for this big plunger to go in, the small one has to be fully out, which, as you can see, when it's sitting like there, this one is held back on the strike plate. Not sure if you can see that. And if I push the door, there's no way I can push it back far enough for it to go behind the strike plate. So when it's held right about there like that, there's no way to push the main one in unless it's fully out. So to demonstrate this exit button, I can take a jumper like this guy right here. If I bend that a little bit smaller and short these two right there, not really as short, but you might have been able to hear that click. Door one open. Sorry, that relocked behind me. But if I push this, there you could hear it lock again. That will unlock it. So if you had a push to exit button mounted somewhere like right there, like a momentary normally open switch, that would also open the door. This reader right here also wasn't the original one to come with the system. I like this one better because it's metal, it's got plastic on the inside, and it looks better. This is the original one that actually came with the system. It's kind of ugly. It's kind of just got these push buttons on here for password, and it can read a fob. I just don't really like it. It's all plasticky. This one feels a lot better. One thing I don't like about it is that there is a Phillips screw at the bottom. I would prefer a tamper-resistant screw. I'd prefer a tamper-resistant screw because, as the name implies, they are more secure because you need a tamper-resistant screwdriver to open it. Because assuming you could get this off the wall and pull it out and expose the wires, so what you could do is it'd be kind of a pain in this case, because I have the wire going all the way through into the junction box on the other side where it's spliced, so it's actually really tight. There's not much play. So if you could get this off, you'd probably break the terminations on the inside, so then what you're about to do wouldn't work. But if you could strip off some of the outer sheathing and expose the two communication wires and maybe the positive and ground to power the device, there's something that can actually go onto your communication wires and can basically see the non-encrypted data that's getting passed back and forth, so then it could see what credentials are opening the system and what credentials are not, and then in that case you'd be able to make a fob that could open the door. Or sometimes you can replay those credentials to unlock the system, which is another problem with unencrypted data, but that's okay. Someone really wanted in. There's many other ways I could go in, like smashing the windows or trying to pick the lock or bump it, or some other fashion of opening the actual lock, not going for the electronic side of it. Just since it's kind of cool, I'm going to take one of these fobs here, and to show you what I was talking about earlier, I'm going to shine a light on the other side of it. So with the light on the back, I'm not sure if you can see that, but there's a coil going around right there, and off to the side right here we have the chip. So this coil just takes the power that the fob reader is giving out, and then this chip is what communicates, basically saying, hey, this is what my credentials are, and passes it back onto the fob reader, and then the access control panel will decide if this fob is granted to have access or if that is denied. I'm not sure if you can tell, but I have the small fob now, not a card this time, but you can still see that smaller wire running around the perimeter of it, and then you can still see the chip. So it's the same thing, just with a smaller coil. So anyways guys, that is kind of my update on the access control system. If you have any other questions, leave those down below, and if I see lots of questions about the same thing, I'll make another update video from time to time on the access control system. So that's about it for this video, but if you enjoyed it, make sure to hit the thumbs up button, and if you haven't already, make sure to subscribe. Thanks for watching.